everybody, we're getting ready to do lesson 3.7 of our SAT Math Prep Level 1. Here's my contact email. 3.7 Systems of Equations. We have 54 points of notes and then 78 points on the skill sheet, which you will not see on this video, but you can get that if you email me. Notebook, this goes in your notebook. A system of equations is a set of equations whose solution make each of the equations true at the same time. SAT questions involving systems of two linear equations with two different variables can usually be solved by substituting the solution of one equation into the other equation. To solve this, you got to eliminate one of the variables in that equation, or adding or subtracting corresponding sides of the two equations so that the equation with only one variable results. More notebook, another notebook entry, page 2. Solving a linear system by substitution. To solve a linear system using a substitution method, pick the equation which is easier to solve. And then after solving the equation for that variable, plug that solution into the other solution in the linear system. Here's the example here. It is easy to solve the second equation for y, which gives y equals negative 2x plus 4. Plug that solution into the first equation to eliminate. And that's what we do here. 2 times that solution minus 3x equals 29. Y. We multiply through here with our 2. We get this. Further simplification, negative 7x equals 21. And then x equals negative 3. The way you solve by eliminating one variable. To find a corresponding value for y, substitute negative 3 for x in the simpler of the two original equations. So we plug that in there. Y minus 6 equals 4, y equals 10. The solution is negative 310. System of equations. Here's another example here. An automobile repair shop wants to make a solution that has 35% pure antifreeze with another solution that has 75% pure antifreeze. How many liters of each solution must be used in order to produce 80 liters of solution that has 50% pure antifreeze? Well, use x and y to represent the number of liters of 35 and 75% respectively. In a mixture, the problem has two conditions. A mixture will contain 80 liters of solution, x plus y equals 80. And then the other one, the sum of the number of liters of in the two ingredients must be equal to the number of liters of pure antifreeze in the mixture. So 0.35x plus 0.75y equals 0.50 times 80 here equals 40. Represent the two conditions by a system of linear equations. X plus y equals 80. 0.35x plus 0.75y equals 40. Here's our two conditions here. From the first equation, y will equal 80 minus x. We plug that into the second one, and we get this statement here. Combine like terms, we get this, negative 40x equals that over there on the right side. We divide through by negative 40. We get x equals 50. So that would be our solution. We go back into the original by plugging in that number. Thus 50 liters of 35% solution and 30 liters of 75% solution must be used. So that is one way that you can solve a word problem by using a system of equations. Solving a linear system by combining equations. In the system here, the numerical coefficients of y are opposite, so adding corresponding sides will eliminate the y here. So we get 2x equals 6. Solve for x and we get 8. Find y by substituting 8 for x in either of the originals. So we can plug in 8 there. 8 plus 2y equals 11. 2y equals 3. Y equals 3 over 2. So that's to solve a system as well. This is notebook again. Here we have another system here. What order pair represents solution to the system of equations here. Rewrite each equation in standard form. Ax plus by equals c. Ax plus by equals c. We need to move that one over. 3x minus 5y equals 19. 3x plus y. So there's our ax plus by equals c. Eliminate x by subtracting the second equation from the first. So here we go. We have this here. So if we eliminate x by subtracting the second equation from the first, we get negative 6y here, because this becomes negative and this becomes negative. So when we combine these two after that, we get negative 6y equals 12, and then we solve for y. Solve for x in the first equation by substituting negative 2 for y. 3x equals 5 times negative 2 plus 19. And then we get down here, x equals 9 over 3, x equals 3. The solution here is 3, negative 2. So that would be how you would use equations to solve for x and y. Solving a linear system by using multipliers. Before corresponding sides of equations in a linear system, it may be necessary to first multiply one or both equations by a number that makes the same variable, and both equations have numerical coefficients. So I think we can do that in this situation here. What order pair represents solution to the system of equations above. So write the first equation in the standard form. And negative 3x plus 4y equals 11. So we bring this over here, and it becomes negative 3x, and 6x minus 5y equals negative 15. Then when we further combine that, change the coefficient of x in the first equation to negative 6 by multiplying the equation by negative 2. So we're going to multiply this, not by negative 2, but by positive 2. Then we add here negative 6x plus 8y. That's what this becomes, is this. And then we combine these two. Then we have 3y equals 6. Y equals 2. So we got 1. We got y. Find x rather by substituting 2 for y in either of the originals. So we can put 2 in here, in this one here, 6x minus 5y. We solve when we get x equals negative y. So there's our solution, negative 1, 2. So that's how you do it. And you find one, you eliminate one variable, then you solve for it, then stick it back in one of the originals. Here's another combination here. What is the value of the product of x, y? Solve the system to get the values of x, y. Rewrite the first equation in ax plus by equals c, so we got to move this one over here. 2x plus 3y equals negative 6. We moved our 2y over there. Eliminate y by multiplying the first equation by negative 2, multiplying the second equation by 3, and then adding the corresponding sides of the two resulting equations. So we have to manipulate both of them now. We multiply the first one by negative 2, then the second one by positive 3, get negative 4x, but we get this here, so we can eliminate our y here by doing this manipulation over here. Find y by substituting 3 for x in either of the two originals, so we just plug it in the first one, and then we can solve for y. 2y equals negative 8, and then y equals negative 4. So that is how you do it. Then we stick that back into this one. 3 times negative 4 equals negative 12. That was our original. So page 21 here, store that has this here. The cost of faxing 5 pages, $305. Faxing 13 pages, $665. What is the cost of faxing 1 page? So we have initial page, and y is the cost of any additional pages. X plus 12y equals 665 is what we have. Then we have x plus 4y equals 305. So we have two facts here that we can line up here. Solve for x by multiplying the second equation by negative 3. So we saw multiply this by negative 3. If x represents cost of x initial page and y cost of x in each additional page, then x plus 12y equals 665, and then x plus 4y equals 305. Solve for x by multiplying the second equation by negative 3. So we're going to do that. And this is what you get here, negative 3x minus 12y minus 9.15. And then we have our first equation here. So when we combine these two, we get this here. We get negative 2x plus 0 equals negative 250. Then negative 2x divided by 2. And then we divide this side by negative 2. X equals 1.25. The cost of faxing one page is 5. And then the additional page would be this, solve for y in the second equation. We stick that back in up here, and then we get y equals 45 cents. So our solution, cost of faxing 3 pages is the sum of the charges of the first page and the 2 additional pages. So x plus 2y equals 1.25 plus 2 times 45 equals 215. The cost of faxing 3 pages is $2.15, and that was done by equations. Solving other types of system of equations, more variables, you may be asked for some combination here. So page 24, 2r equals s. What is r in terms of s? Ask for r in terms of t. Work toward eliminating s. Substitute 2r for s in the second equation. So 24t equals 3s equals 3 times 2r equals 6r. So if 2r equals s, then 3s, 3 times s would equal what? 6r down here, 6r here. Then 24t would equal 3s, which equals 3 times 2r, which equals 6r. Solve for r in equation 24t equals 6r. So we have equated 24t equals 6r. 24t we divide through by 6. We get 4t. We can stick that one back now. If ab minus 3 equals 12 and 2bc equals 5, what is the value of a over c? Since the question asks for a over c, you must eliminate b. Find the value of ab in the first equation. Since ab minus 3 equals 12, then ab equals 15. To eliminate b, divide corresponding signs of ab equals 15 and 2b 5. So we have ab over 2bc equals 15 over 5. And then we have ab over 2bc equals 3. So a over 2c would equal 3, because these would cancel out here. Solve the resulting equation for a over c. So solving for a over c, we get a over c equals 6. The value of a over c is 6, and that would be how you would do that. If you want the worksheet for this lesson here, or if you want the PowerPoint or video so you can watch this again, then contact me here at this email. Thank you very much.